Hey y'all, this is Geometry Lesson 3-5. We have been learning about the slopes of lines, and we need to use this video just to cover the last page of the lesson. So please turn in your book to page 184, and again, this is Lesson 3-5. And let's just start with a really quick review. So we talked about how slope is represented by the letter M. Let me turn the camera just a little bit. Represented by the letter M always. And we said the slope formula is the change in rise over the change in run, or rise over run. I'll write that up here. Slope equals rise over run, or the change in y's over the change in x's. All right, so let's look at the last page of the lesson, page 184 at the top. The slopes of parallel and perpendicular lines. The parallel line theorem says, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. All right, so what this is saying is that any two lines on the coordinate plane that have the exact same M or the exact same slope are in fact parallel. It's also saying that any two vertical lines on the coordinate plane, remember their slope is undefined, but any two vertical lines on the plane, on the coordinate plane, are going to be parallel to each other because they're all running vertically right beside each other. So vertical lines are always going to be parallel, and any two lines on the graph that have the same slope are also parallel. All right, now let's look at the next one, the perpendicular lines theorem. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical lines and horizontal lines are perpendicular. Okay, so there's really two parts there that we need to talk about. Let's talk about the last part first. Vertical lines are, of course, perpendicular to horizontal lines. And I'm going to put my book down just so that we can look at that. A vertical line, if it's perfectly vertical, is always going to be perpendicular to a horizontal line if it's perfectly horizontal, which mine is not. But vertical and horizontal lines are always going to work together to make 90-degree angles or right angles. Therefore, they're always going to be perpendicular. All right, so that's the second part of that definition. Now let's look at the first part of that definition, that the slopes of two lines that are perpendicular to each other are going to have a product of -1. So let's look at what that means. If we had a slope on one line of 5/4, and we had a slope of line 2 that was 4/5, let's multiply those together because the product is the answer to a multiplication problem. So what is 5/4 times 4/5? Oh, I'm sorry, one of these had to be negative. So this slope is negative. Remember on our graph, a positive line would be going that way, and a negative line would be going this way. So -4/5 and positive 5/4, and we're going to multiply them together. What is 5 times -4? It's -20. What is 4 times 5? It's +20. That equals -1. That means the product of these two slopes is -1. Another way that this is the way that I tend to think about it more, is that when we have perpendicular lines, their slopes are opposite reciprocals of each other. Hopefully you remember that a reciprocal is an upside down fraction. So if we have the fraction 5/4, its reciprocal is 4/5. And when we say the opposite reciprocal, we're talking about the opposite sign. So since this one was positive, this one must be negative. So hopefully you see that this is the negative reciprocal of this. Or this is the opposite reciprocal of this, because if this is negative, then this one's got to be positive. So slopes of perpendicular lines are opposite reciprocals of each other. All right, let's do a little practicing with that in mind, and I have to be careful to keep the video short enough that I'm able to upload it. So let me look at, let's see, example 3, letter A. Y'all look at this with me. Determine whether these lines are parallel, perpendicular, or neither. Graph each pair of lines and use their slopes to determine whether they're parallel, perpendicular, or neither. Okay, so we need to talk about this. I I don't need you to graph this. You're welcome to, but you cannot determine your answer by graphing. If you turn the homework in and all you've done is graph, then that's not going to be acceptable for me, because we are supposed to be figuring this out mathematically with our y2 minus y1 over x2 minus x1, or slope formula. So it's fine with me in this lesson if you don't graph it, period. Then homework instructions will probably tell you to. I'd rather you just do it mathematically. Okay, now that only goes for this lesson, of course. All right, so look at example A. We have line AB and line CD, and you can see those lines drawn in the graph on your page. We have the points for each line. We have A is 2 and 1. We have B is 1 and 5. We have C is 4 and 2, and D is 5 and 2. So for line AB, here are the points we have. A is 2 and 1, and I'm just doing it over near the A, and I'll do B over near the B, 1 and 5. And then we have line CD. Sorry, forgot what I was doing there for a second. Okay, C is 4 and 2. D is 5 and negative 2. Okay, let's look at this. We need to find the slope for this line, and then we need to find the slope for that line. That's the only way that we can compare the slopes. So let's use our slope formula for this line. M equals y2 minus y1 over x2 minus x1. I'm going to let B be the second one. So I'm going to say y2, which is 5, minus y1, which is 1. 5 minus 1 over, I'm making sure this is in my window, x2 minus x1, 1 minus 2. Remember, I could have gone the other way. As long as I move in the same direction both times, I'm fine. So this slope is going to be 4 over 1 minus 2 is negative 1, or overall it's just a negative 4. All right, now let's do this one, line CD. M equals y2 minus y1, negative 2 minus 2. Negative 2 minus 2 over 5 minus 4. 5 minus 4. Negative 2 minus 2 is negative 4. 5 minus 4 is 1. So again, my answer is negative 4, and I'm hoping that that also is in the window. Yes. All right, look at my slopes. What do you notice about the slopes of these two lines? They are the same. If their slopes are the same, that means that they are parallel. All right, pretty cool stuff. Let's do another one. Let me check the time on the video. Yeah, we're doing okay. All right, the next one, we're going to find lines ST and UV. And while I write it on the board, you can look at it graphed in the book. Line ST, line UV. And I'm going to put in these coordinates because it's easier for me. Y'all know that I'm very visual. It's easier for me to look at it this way than it is to see this list in the book. So that's just, obviously that's just me. But you might find that you need a little more order too by draw, 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 label, label, labeling. Okay, so now again, we need to find the slope of this line and the slope of this line, and then compare to find out if they're parallel, perpendicular, or neither. All right, let's look at it, and let me make sure you've got all this in the window. Yes. Okay, so for this one, M equals y2 minus y1 over x2 minus x1. I would like for you to write this in every problem. It should be a part of every problem so that you're memorizing it as you write it and learning it as you write it. So let's plug it in. I'm going to say t minus s. So M equals minus 1 minus 2, or y2 minus y1, over x2 minus x1. That's 5 minus negative 2. 5 minus negative 2. All right, let's do the math. 1 minus 2 is negative 1. 5 minus negative 2 is 5 plus 2, which is 7. So we have negative 1 seventh. I don't think I did something right there. I didn't do something right there. Give me just a second. I see why, and y'all probably already caught it. I didn't see this negative sign right here. So this is negative 1 minus 2, which is actually negative 3. Sorry about that. I knew something wasn't right. Okay, now let's do the slope of this line. All right, M equals y2 minus y1, negative 4 minus 4. Negative 4, this time I'll try not to overlook my negative sign. And x2 minus x1, negative 1 minus 3. Negative 1 minus 3. Negative 4 minus 4 is negative 8. Negative 1 minus 3 is negative 4. The answer is positive 2. Let me see if that's still in your window. It is. All right, let's compare these slopes. Are they the same? Absolutely not. Are they opposite reciprocals? No, the opposite reciprocal of this would be positive 7/3. Or the opposite reciprocal of this, remember this is really a 2 over a 1. So the opposite reciprocal would be negative 1 over 2. Remember, you got to do the opposite before you do the reciprocal, and that changes your sign. So they're not parallel, they're not opposite reciprocals, so they're not perpendicular. So these are just intersecting lines. They're neither perpendicular nor parallel, but since they're not parallel, they are going to cross at some point unless they're skew, but they can't be skew because they're in the same plane on the graph in the book. So we know they're going to intersect at some time, but you can say neither here if that's your only option. All right, the last one. Let me check the time again. We're good. I'm sure it's a little weird when I put my head down to the video to see what time it is. Okay, last one. This time we're going to do it for FG and HJ. Line FG, line HJ. Now, these may be too small for you to read. I'm sorry if they are, but for my own sake and visual needs, I'm going to plug these in with the letter. So F's coordinates are 1 and 1. G's coordinates are 2 and 2. H's coordinates are 2 and 1, and J's coordinates are 1 and 2. Okay, let's do our slope formula. All right, remember, write this in your problem. M equals y2 minus y1, or the change in rise, over x2 minus x1, or the change in run. Slope equals rise over run. You need to be wrapping your head around that. All right, so let's plug it in. M equals, I'm going to move in this direction, so I'm going to say 2 minus 1 over 2 minus 1. 2 minus 1 over 2 minus 1 is going to give me 1 over 1, or just 1. All right, let's look at this one. Slope equals y2 minus y1 over x2 minus x1, or change in rise over run. All right, I'm going to go in this direction again. 2 minus 1 for my y2 minus y1, 1 minus 2 for my x2 minus x1. 2 minus 1 is 1, but 1 minus 2 is negative 1. So let's look at this. I'm going to go back to this one because it's still written as a fraction, even though it's the same as that. And I need to compare it to this one. Are they parallel? Are they identical? No, look, this one has a negative sign. So here we have 1 over 1. Here we have negative 1 over 1. So they're not parallel because they don't match. Are they opposite reciprocals? Is 1 over 1 the opposite of 1 over 1? Yes, in a backwards thinking sort of a way. You've got the same numbers there, but obviously if you turn them upside down, they're still going to say the same thing. Now, is it the opposite reciprocal? Yes, because the top one is positive and the bottom one is negative. So we've got positive 1 over 1 and negative 1 over 1. Or we could have just written the answers like this. So these lines are in fact perpendicular, and I just think that stuff is so cool. So your answer there would be perpendicular. But you have got to show all that work. You absolutely, on these questions, cannot put as your answer parallel, neither, perpendicular. You've got to do everything that I just did in order for that answer to be correct on your homework. All right, that is the end. There are 3 more examples in the check it out underneath what we just did. They are 3A, 3B, and 3C. And the answers to those are in the back of the book, I believe. So that would give you more practice if you need it. Now remember, I encouraged you in class today, use the videos. Don't come back confused not having done that. Use the videos. They are amazing resources that are there for you. All right, hope y'all have a great weekend.